is radioactivity or radioactive decay? So it's the decay or changing of the atomic nucleus into something new-ish. So it's basically when you change from what your original nucleus is and you undergo some process and it changes in to something else. Okay. It's changes, and the key is it's changes in the nucleus. So this is changes that happen in the nucleus, as opposed to changes that happen in like changing electron orbits or something like that. It's something that's happening inside the nucleus itself. All right. So which things are radioactive? And that would be anything above lead, which is atomic number of 82. So anything above lead is radioactive. Now, some of these things are not very radioactive. Like, just because it's radioactive doesn't mean it's dangerous. And just because it's radioactive doesn't mean it's incredibly radioactive. For example, there's lots of different types of uranium. And what I mean by that, there's things called isotopes, which are basically just uranium, but with different numbers of neutrons. Depending on what type of uranium you have, it's either very radioactive or not very radioactive. Yeah, 235 versus 234 versus 236. So depending on what type of uranium you have, it's either very radioactive or not. And so just because it's radioactive does not mean it's dangerous. And just because it's above lead doesn't mean it's incredibly radioactive. You're thinking about like a periodic table. So let me give a common one. So if you look at like yeah, that would work. Like, trying to think of one that you're used to. Yeah, the ones I'm thinking of. So like things that are above lead are things like radon and radium and uranium and that kind of stuff. Like those kind of things tend to be the things that we're talking about. Okay. All right. So there are 3 types of radiation that we're talking about here. So list each one, describe what each one actually is. So alpha decay is a positive charge. And what it actually is it's a helium nucleus, which is 2 protons and 2 neutrons. Okay, so if something undergoes alpha decay, it shoots off positively charged helium nuclei. That's what it is. Okay? So it shoots out a helium nucleus. Okay? Uranium does this. Uranium does alpha decay. So uranium shoots out these little helium nuclei. Okay? So that's alpha decay, or alpha particles. So beta particles are negatively charged. And these are electrons. Okay? Lots of different things will do beta decay. Thallium, lead does sometimes, bismuth, like alpha decay or beta decay we'll talk about, but it's basically shooting out an electron. Now, be careful. This doesn't mean an electron comes off of the atom. An electron shoots out of the nucleus. Which we'll explain why, because that sounds weird, because electrons aren't in the nucleus, they're around it. So how are electrons magically shooting out of the nucleus? We'll get there. But a beta particle is just an electron. Okay? Gamma particles have no charge. And they are high energy electromagnetic waves. All right, so alpha decay, positively charged. It's a helium nucleus. The reason it's positively charged because it's got 2 protons but no electrons. Beta decay is negatively charged because it's just an electron. And gamma particles have no charge because there aren't particles, they're waves. Okay, there's high energy waves. And if you remember back to the electromagnetic spectrum, okay, so it's radio waves, microwaves, infrared, visible light, X-rays, ultraviolet, X-rays, gamma rays. Gamma rays are the highest ones on the electromagnetic spectrum, and here they are. Okay? They're also called gamma particles. That's the technical name, but we call them gamma rays a lot. All right. So what particles are labeled as nucleons? That would be protons and neutrons. Okay? Those are the particles that make up the nucleus. Remember, they're really tiny and really small and close together. And then 5, what are quarks? Now, when you were a little kid and you were talking about atoms, your teachers probably told you there were the 3 smallest things are protons, electrons, and neutrons. They probably told you those are the 3 things that make everything up. And they lied to you. I'm sorry. Although in this case, I understood why they lied to you because the actual thing is very complicated for like a 7-year-old. But protons and neutrons are actually made up of things called quarks. So protons and neutrons and other nucleons, so this includes antiprotons and antineutrons, so the opposite version of these, are made up by quarks. Okay? Quarks are little bitty tiny things that, when they combine together, make these things. So first of all, it always takes 3 quarks. It takes 3 quarks. And depending on which 3 quarks you get, depends on what nucleon you get. So like if you add 3 of, so there are 6 types of quarks. I'm not going to make you memorize or know what the 6 types of quarks are. You should know that there's more than one. It's not just like one thing. Okay, there's 6 types of quarks. I will also not make you memorize their names, but here are the 6. Up, down, top, bottom, strange, and charm. Those are the names. I'm not making that up. The actual names of the quarks are top, bottom, up, down, and strange and charm. strange. Yeah. Strange quark. The strange quark. Strange quark's weird, man. Not to be confused with the charm quark, which is not as strange. See what I did there? See what I did there? Yeah. If you're wondering what's the difference between them, the difference between them is how much they weigh, how much mass they have, what their charge is, and what their spin is. Spin is something we haven't talked about. We won't talk about it until maybe quantum mechanics. Spin is just a measure of like what the particle does. So if you think about spinning, like is it spinning around this way or is it spinning around that way? Okay, so spin, charge, mass, depending on which quark you have determines what it is. Okay, and you combine three of them together and then you get a proton or a neutron or whatever it is from there. So again, I'm not going to make you memorize the types or anything like that. You should just know that they make up protons and neutrons. They're small, and it takes three of them to do it. Okay? All right. Those are called fermions is the name for them, but we're not worried about that. Fermions. Fermions, as in Enrico Fermi. Or Fermi Lab, which is in Chicago. Not Fermi. Okay? All right. So we learned in the electricity chapter that you're going to do next semester. So you're going to learn in the electricity chapter that positive charges like protons repel. So how are multiple of them held closely together in the nucleus? So here's my nucleus. I got a proton. I've got a proton. I've got a proton. And I've got a proton. So first of all, they want to repel. They want to go away from each other. And that's called the electromagnetic force. They want to go away from each other. So, why don't they? I heard someone say gravity. That is a tremendous guess. Tremendous. Was that Jack? Was that Jack? Jack, was that? Tremendous, Jack. It's wrong, but that's a really good guess.
I told him to guess that.
It's not, you told him to. It's not gravity. So let me explain why it's not gravity. Gravity is really small unless the masses are really big. And the masses are not really big. So it's not gravity. Gravity is just too small. It is called the strong nuclear... Well, this one's not ridiculous. It's kind of ridiculous. So it's called the strong nuclear force. It's the strong nuclear force. And if you're wondering why it's called the strong nuclear force, it's because it is the strongest force known to man.
Wow.
Yeah.
So what would it do to a human?
We'll get there.
Oh.
We'll get there. So the strong nuclear force...
Don't you make him radioactive by putting
We'll get there. Yes.
bombs?
Stop
Yeah.
jumping ahead.
Jack's just all over it today. He wants to learn. Jack wants to learn. He woke up this morning and said, man, I hope we learned about nuclear decay today.
Oh yes, that's what
It's
you
for
do.
you. That's what Jack's always worried
That's
about.
what you do when you.
That's what he said every day. He's just been disappointed until today.
I've been waiting. That's what you do when
Glad.
you get 2 pieces of uranium and surround them in lead.
Sure. So, strong nuclear force. And the thing you should know about the strong nuclear force is it is between nucleons, hence the nuclear force. So, like it's between protons and between neutrons. And it's an attractive force. Yes. What I mean is that it's handsome to look at. That's what I mean by attractive force. Excellent job, Peyton. I means it pulls things together, right? So it's an attractive force, and it's between nucleons. It is larger than the electromagnetic force. Okay? Indeed. Well, it's at least normally bigger than that. All right.